Hi everyone, and welcome back. My name is Theo, I'm an engineer, and in this video we're going to talk about Python conditions, the logic that allows programs to make decisions. We'll see how programs think step by step, how Boolean logic controls the execution flow, and how to write clean, readable, and professional conditional statements. Let's get started. Now let's answer a fundamental question. Why do conditions even exist? In programming, we constantly need to make decisions. A program should not always execute the exact same instructions from top to bottom. Sometimes, it needs to choose what to do depending on the situation. For example, if a user enters the correct password, we grant access. If a KPI goes above a certain threshold, we trigger an alert. If someone is under 18, we deny access. If a stock price drops below a specific level, we might decide to buy. All of these situations have something in common. The program must evaluate something first and then decide what to do next. And that's exactly what a condition does. In simple terms, a condition allows your program to choose. Without conditions, a program would just execute instructions line by line, with no intelligence, no flexibility, and no adaptability. Conditions are actually the foundation of decision-making, validation, automation, control systems, AI logic, and even business rules. Let's look at a very simple example. Here, we define an age variable equal to 20. Then we check. If age is greater than or equal to 18, we print access granted. The program evaluates the condition. If it's true, the code inside the block runs. If it's false, it simply skips it. Let's see a second example, a threshold logic. We define a KPI value and a threshold. If the KPI is above the threshold, we trigger an alert. This is extremely common in monitoring systems, finance, logistics, basically everywhere in engineering and business. To conclude, a login system. We compare the entered password with the correct password. If they match, we print login successful. This is real-world logic. This is how authentication systems work at a basic level. So, to summarize, conditions allow programs to make decisions. They let the program choose between different actions. They're essential for automation and logic. And without them, programs cannot adapt to situations. Now, before we go further with conditions, we need to clearly understand what a condition actually is. A condition is simply an expression that evaluates to either true or false. Nothing more than that. In Python, these two values belong to a special type called bool, which stand for Boolean. And it's very important to understand something here. True and false are not strings. They are real Python values. If we check their type, we can see that both true and false belong to the class bool. Now, how do we actually create conditions? Most conditions are built using comparison operators. These operators compare two values and return a Boolean result. And here is the key idea. Every comparison returns either true or false. Let's look at some examples. If we compare numbers like 5 greater than 3, that returns true. 10 less than 4, that returns false. 7 equals 7, true. Same logic works with variables. If x is 15 and y is 10, x greater than y is true. X less than or equal to y is false. Comparisons also work with strings. If we compare apple and banana, Python compares them alphabetically. So apple is equal to apple, true. Apple equals banana, false. And apple comes before banana alphabetically, so that comparison returns true. Now, very important point. Double equal sign checks for equality. Single equal sign assigns a value. So, x equals 5 means we assign 5 to x. X equals 5 means we compare x to 5. Confusing these two is one of the most common beginner mistakes. So to summarize, a condition always evaluates to true or false. Boolean values belong to the bool type. Comparisons are the foundation of conditions, and every comparison returns a Boolean. Now, in real-world situations, one condition is often not enough. Most of the time, we need to combine multiple conditions together, and that's where logical operators come in. Python provides 3 logical operators, and, or, and not. These allow us to build more complex decision rules. You can think of them like this. With and, both conditions must be true. With or, at least one condition must be true, and not simply reverses the result. Let's look at some examples. Here, we have someone who is 25 years old and has a ticket. We check age is greater than or equal to 18 and has underscore ticket is true. Both conditions are true, so the final result is true. Now imagine another situation. The temperature is 35 degrees and it is not sunny. We check temperature greater than 30 or is underscore sunny. Even though is underscore sunny is false, the temperature condition is true. Since or only needs one true value, the final result is true. Now let's look at not. If someone is not logged in, meaning is logged in is false, then not is logged in becomes true. So not simply flips the Boolean value. To better understand how these operators work, it helps to remember their truth tables. For and, the only way to get true is when both sides are true. For or, you get false only if both sides are false. And for not, it just reverses the value. Now let's see a more realistic example. Imagine a student passes an exam only if the score is above 50 and attendance is above 75. If both are satisfied, the result is true. This is how real decision rules are built. One important thing, when combining conditions, parentheses can really improve clarity. For example, you might have something like score greater than 50 and attendance greater than 75, or bonus points greater than 10. Even if parentheses are not always required, they make your logic easier to read and safer. So to summarize, logical operators allow us to combine conditions, and requires both to be true, or requires at least one to be true, not reverses the result. And parentheses improve readability and help prevent mistakes. Now that we understand conditions and logical operators, we need to use them inside real Python programs. And this is where the if, elif, else structure comes in. In Python, the basic structure looks like this. If a condition is true, the indented block of code runs. If the condition is false, it simply skips that block. And here, indentation and colon are extremely important. In Python, indentation defines which instructions belong to the condition. It's not just for readability, it actually changes how the program behaves. Let's look at a simple example. We define age equal to 20. If age is greater than or equal to 18, we print, you are an adult. Since the condition is true, the message is displayed. Now, what if we want an alternative? That's where else comes in. The else block runs when the condition is false. So age is 16. If age is greater than or equal to 18, print access granted. Otherwise, meaning else, print access denied. Since 16 is less than 18, the condition is false, so the else block runs. Now sometimes, two options are not enough. We may need several possible outcomes. That's where elif comes in, which stands for else if. It allows us to test multiple conditions in order. For example, imagine grading a student. If the score is greater than or equal to 90, grade A. Else if it's greater than or equal to 75, grade B. Else if it's greater than or equal to 50, grade C. Otherwise, grade F. Python evaluates these conditions from top to bottom. The moment it finds a true condition, it executes that block and stops checking the rest. In an if, elif, else chain, conditions are checked in order. Only one block runs, and Python stops at the first true condition. This is different from writing multiple independent if statements, where several blocks could run. So, to summarize, if starts a conditional block, else handles the false case. Elif allows multiple conditions. Indentation defines the scope of execution, and Python checks everything from top to bottom. Now that we've covered the fundamentals, let's look at some useful and Pythonic condition patterns. Beyond basic comparisons, Python gives us elegant and powerful ways to write cleaner conditions. These patterns make your code more readable and more professional. Let's start with membership operators, in and not in. The keyword in checks whether a value exists inside a collection, like a list, a string, a tuple, or even a dictionary. For example, we define a list of allowed users: Alice, Bob, Charlie. If the user is in the list, we grant access. This is much cleaner than writing multiple comparisons like user double equals Alice, or user double equals Bob, or user double equals Charlie. Membership also works with strings. If we check whether py is inside the word Python, Python looks for that substring. And if it finds it, the condition returns true. Now let's talk about something slightly more advanced. Identity operators, is and is not. It's important to understand the difference between double equals and is. Double equal sign checks if two values are equal. The operator is checks if two variables refer to the exact same object in memory. In practice, this is mainly used when comparing something to none. For example, if value is none, we print no value provided. This is the recommended and Pythonic way to check for none. You should not use is for general value comparisons. For equality of values, always use double equals. Now, let's look at something very elegant in Python: chain comparisons. Instead of writing x greater than 0 and x less than 10, you can simply write 0 less than x less than 10. It's shorter, clearer, and very readable. This is one of those small details that makes Python feel clean and expressive. Finally, let's talk about the conditional expression, also known as the ternary operator. This allows you to assign a value based on a condition in a single line. For example, status equals adult if age is greater than or equal to 18, else minor. This is perfect for simple logic, but it should not replace full if statements when the logic becomes complex. So to summarize, in checks membership is checks identity mainly for none. Python supports elegant chain comparisons, and the ternary operator allows compact, conditional assignments. These patterns make your code more Pythonic, more readable, and more professional. Now let's talk about something that's very important in Python, but often confusing at first: truthiness and implicit Boolean logic. In Python, conditions don't always need to explicitly return true or false. Some values are automatically interpreted as true or false when they're used inside a condition. This behavior is called truthiness. Let's start with falsy values. There are a few values that Python always considers false inside a condition. For example, 0, 0 as a float, empty strings, empty lists, empty dictionaries, empty tuples, and also none. So if you convert these values to a Boolean using bool, Python returns false. Everything else is considered truthy. That means that non-zero numbers, non-empty strings, and non-empty collections are automatically treated as true. You can see this clearly in the examples. A number like 5 is true, a string like hello is true, and a list with elements inside is also true. Now, why is this useful? Because truthiness allows us to write cleaner and more Pythonic conditions. For example, instead of explicitly checking the length of a list, like if the length of my list is greater than 0, we can simply write if the list is not empty, the condition is true. If the list is empty, the condition is false. This makes the code shorter, clearer, and easier to read. The same idea works in the opposite direction. If you want to check whether a list is empty, you can write, if not my list. So here, if the list is empty, Python treats it as false and not reverses that to true. This pattern is extremely common in real Python code. So to summarize, Python automatically interprets some values as true or false. Empty values and 0 are falsy. Most other values are truthy. Truthiness allows us to write cleaner and more readable conditions. And it's important to clearly distinguish between 0, empty values, and none when the logic requires it. Now let's finish with some very common mistakes people make when working with conditions. Even though conditions look simple, small details can completely change your program's logic. One of the most frequent mistakes is confusing the single equal sign and the double equal sign. The single equal sign is used to assign a value to a variable. The double equal sign is used to compare two values. So when you write x equals 5, you're storing the value 5 inside x. But when you write x double equals 5, you're asking Python whether x is equal to 5. That small difference might look harmless, but inside a condition, it completely changes what your code does. So always slow down and check that you are using the right operator. Another common mistake is using is when you actually want to compare values. The operator does not check if two values are equal. It checks whether two variables refer to the exact same object in memory. Most of the time, when you want to compare numbers, strings, or other values, you should use double equals. The keyword is mainly used when checking against none. So the safe rule is simple: use double equals for value comparison, and use is mainly when you're checking if something is none. There's also something people often write that is technically correct, but not recommended. For example, writing if is valid double equals true. This works, but it's unnecessary. If a variable is already Boolean, you can simply write if is valid. It is cleaner, shorter, and more Pythonic. The same idea applies in reverse. Instead of writing if is valid double equals false, you can simply write if not is valid. This makes your conditions easier to read and reduces visual clutter. Finally, indentation. Indentation in Python is not just for style. It defines which lines of code belong to a condition. If you indent a line under an if statement, that line will only run when the condition is true. If you move it outside the indentation, it will always run, no matter what. So incorrect indentation can completely change your program's behavior, even if your condition itself is correct. That's why clean indentation is not optional in Python. It is part of the language. If you avoid these common mistakes, your conditional logic will be much more reliable and much easier to read. So let's quickly recap. Conditions allow programs to make decisions instead of just running line by line. Comparisons return true or false. Logical operators help us combine conditions. And the if, elif, else structure controls what actually runs. We also saw more Pythonic patterns like in, chain comparisons, the ternary operator, and truthiness, which help us write cleaner and more readable code. Most importantly, clear logic always matters more than clever tricks. If you understand conditions well, you're now ready to move on to loops, functions, and more advanced programming concepts. And that's it for this video.